This lesson is about finding the least common denominator of rational expressions. We're going to talk about these steps that I highly recommend that you follow whenever you're trying to find the least common multiple or denominator of rational expressions, and then we're going to apply these steps to some examples. Now you may ask, how do I go about finding the least common denominator of rational expressions? The first thing you're going to do is you're going to take the expressions in the denominator and you're going to express them as product of the factors, each of them, and we're going to make sure we pay attention to the exponent form. Then we're going to identify the unique factors in the expression, identify unique factors, and then we're going to choose the largest exponent for each of these factors, and we're going to multiply them together, and that's going to give us the least common denominator or the least common multiple of the rational expressions. So let's see what this all means when we have some questions to deal with. What is the least common multiple or least common denominator of 4 over 2x minus 6 and then x minus 1 over x squared minus 9? So what we're going to do is we're going to pay attention to the denominators only. So let's go ahead and factor these denominators. 2x minus 6, this is going to be 2, and then we have x minus 3. And then I said pay attention to the exponent, so we're going to put to the power of 1. And then we have x squared minus 9. This is going to be x plus 3 multiplied by x minus 3. So exponent also is 1. So your least common denominator is going to be, look at all the factors we have. We have x minus 3 here, x minus 3. So we're going to take x minus 3. And then we have x plus 3 here as well, x plus 3. And then we only have exponents of 1. So we can do this right here and this right here. And then you can choose to leave it this way because it's when you have to use this for addition and subtraction of rational expressions, it makes more sense to leave it in that form. And so I think we can leave it in this form as x minus 3 and then x plus 3. The next example, so we have the least common denominator of these rational expressions. We're going to pay attention to just these two. So x squared minus 4x plus 4. This is going to be x minus 2 multiplied by x minus 2. And then we are paying attention to the exponent, so this is going to be x minus 2 squared. And then the second one here, we have x squared minus x plus 2. So this is going to be x minus 2 multiplied by x plus 1. We pay attention to exponents here, so we put the exponent of 1. So the least common denominator, we have x minus 2. And then we have x plus 1. So what are we going to do? We're going to pick the highest exponent. So we have x minus 2 squared here, x minus 2 to the power of 1. I'm going to choose x minus 2 squared. And so this is going to be our least common denominator. Here, I mean, you can put a 1 here and then go one more step and go x minus 2 squared and then x plus 1. So that's the final value for the least common denominator of these two expressions. And then final example here, so we have x squared plus x minus 20. This is going to be x plus 5 multiplied by x minus 4. And then the second one here, we have x squared minus x minus 12. This is going to be x minus 4 x plus 3. So I'm going to pay attention to exponents. So that's very important. And so your least common denominator is going to be, let's look at all the expressions that show up in our factors. So we have x plus 5, we have x minus 4, and then we have x plus 3. And all of them have an exponent of 1. So this is what we're going to do. So this is going to be x plus 5 multiplied by x minus 4 multiplied by x plus 3. So this is going to be the least common denominator of these rational expressions.